Hey everybody, this is Larry. This is day 18 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Only 2 more weeks to the end of the year. How did you do this year? Let me know in the comments below or come to Discord, just hang out, chat about it, whatever you want to do. Okay, so this is a hard problem, so it may take a while. So yeah, feel free to watch it on the fastest speed or watch it on 2x, or I guess that is the fastest speed, or just skip ahead, whatever you like to do. Just giving you options, and if that doesn't work for you, I'm sure you could find another video that does it, like people who keeps on telling me to switch to other languages. Well, use other videos, it's fine. I'm gonna keep doing it in Python for as long as I want to. Anyway, today's problem is, given an array of digits which is sort of a non-decreasing order, you can write I guess I didn't read the name yet, which doesn't really matter, but all right, let's do it. Numbers at most n given digit set. Okay, that's a really awkward sentence, I guess. Anyway, for example, 1, 2, 5, we made 1, 3, 5, 5, 1, 1, 3, 1. Okay, so we can do that as many times as we want. Return a number of positive integers that can be generated that are less than, or you go to a given n. Okay. Let's see. So, let's see, right? I mean, the first thing I'm thinking of to be with these things, to be honest, is going to be brute force. And seeing. And that's why you saw me scroll down for a quick second, see if that's possible. If this is 9, then and n is 10 to the 9th, that means that there are. I mean, there are 10 digits, but I guess like 1 billion exactly isn't it? It's fine. And there's no zeros anyway, so there's gonna be 9 digits each from 1 to 9, so that's like 9 to the 9. 9 to the 9 isn't as big as 10 to the 9, but it is still pretty big. Happens to be 387 million, so that is not going to be great. Digits is sorted in non-decreasing order. What does that mean? Can there be repeats, or what does that mean? Like, why is it not just increasing if it's unique? Okay, I mean, okay, that's just like that's a weird way of phrasing it if it is unique anyway. So because increasing order is the same as non-decreasing if it's unique, right? So anyway, okay. So I think let me think about this, right? So the second thing that I might think about is kind of actually I took a quick glance at this one, and it gives a hint, right? Of okay, how many ways are there to have a number of n digits, right? And then the next thing you're gonna ask, or I'm asking anyway, right? So let's say we only care about the number of digits. Then I think the math is pretty straightforward. It is for k digits, k to the x or whatever, right? Because it's just all possibility. So that means that we have a way to get the answer for n is equal to 1, n is equal to 10, n is equal to 100, and so forth, right? Dot dot dot. And then the question is, okay, but then this obviously doesn't solve the question of, like, let's say what if n is equal to, like, I don't know, some random number, right? Well, then the question is going to be equal to the number of ways that n has a 1 prefix plus 3 digits, right? 3 random digits, or 2 plus 3 digits, dot dot dot. So you have a for loop here that's gonna be dot 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 all the way to n is equal to 5. Well, okay, let's actually not skip the dot 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 because we're almost there. Oops, how did I digits? Plus 3 digits, and then n is equal to 5. It's not quite right? Because then now you could do 5 0, though technically the 0 is not a possible thing, so we'll skip that a little bit. Plus 2 digits, right? Oops, how did I keep on typing digits? And then there's no 5 2 because n is 551. So then that's actually then this is not even true. Okay, I'll get to the 1 in a little bit. So let's swap the 2 and the 1 for a second. So then here 5 2. Well, we know that this is not true anymore, right? Not true. So then that means that we actually won 5021, which is also not true. You cannot do this plus 1 digit because the digit is constrained. So then you do it from 5111 plus no digits, and then n is equal to 5212, and then n is equal to 5213, or so forth, right? Plus no digits. and then whether they're possible. I think that is going to be the way to do it. And if I'm correct, right? Oh yeah, and of course, you can kind of have an implicit n is equal to 3 digits, n is equal to 2 digits, and so forth. I was just doing about 4 digits number, right? So that's kind of like the idea that I'm playing with. And of course, yeah, I mean, I think from here, so the second dot, which I got distracted about, that I was going to say is about the complexity, right? And you can kind of see from this complexity that even if n is equal to, say, 99999, we are going to do, like we're just going to have a for loop that goes from, 1 and then 2 dot 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 dot. This time I'll dot 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 it, and then 9 and then 1 and then dot dot dot, right? N is equal to 92 dot dot dot. N is equal to what we want to do is let's just say 98, and then next one is going to be 991, right? For example, right? So whoops, I added an extra, but okay. But you get the idea. And of course, in this case, you're gonna move the first digit 9 times, second digit 9 times, third digit 9 times, dot dot dot, and so it is only 9 times the number of digits, which is like we said before, 9. So it's gonna be at most 81 or 81 iterations of the loop, depending on what the cost of these things are. So let's get started. I think that's enough for, basis for how I would approach this problem. I don't know if I've seen this one before, probably. I don't know. Or like, I probably have seen it before, but I don't remember it. So hopefully this is helpful. But yeah, so then here, let's have, at least for me, you could have two, as many functions as you like. But the way that I'm going to do it is maybe I'll have 2 functions at least. One is n digits to kind of, oops. And here, that is just going to be, I'm going to call this k. So then I could use n is equal to the number of digits. Maybe that's not the reason. Okay, never mind. Actually, I'm going to make this k just n, and then I'm going to write d is equal to the number of digits. And then this is just d to the power of x, right? Yeah. This is, and of course, let's document our code a little bit so we don't forget, at least for me. So number of possible numbers with x digits, right? Okay, and then now we can do a for loop with, let's just say we have total is equal to 0, and then how do we want to say this? Okay, so we can do it in a number of ways. Let's just say digits is equal to 1, and then how do we want to say? I mean, there are a couple of ways you can do it. So the way that I'm iterating now is just this part. Yeah, I mean, do for. This is where I like for loops in non-Python languages, because then I could just terminate as soon as we care about. But yeah, so then yeah, so okay. Yeah, let's just do this silly way. Let's convert to a string, and then the number of digits is, so the length is the number of digits, and we want this, let's see, so I'm just thinking about the edge cases of, let's say we have 100, so that's 3 digits, so we only want up to 2 inclusive, so I guess this should be good. So then now for I in range of this, we can do, how did I forget it? Okay, total n digits of I, right? And this is gonna work because, is it? I'm just double checking whether I've off by 1, because for 0 digits, I guess 0 digits don't really exist. So yeah, so okay, let's just start from 1 then. Yeah, okay, I think we're good here, though we'll double check later. That's what testing is for. And then of course we'll return total at the very end, and we don't have to worry about model overflow because, well, total can at most be n, right? So yeah, and also with timeout before it overflows. So okay, maybe anyway. Okay, so then now for the last digit, we can construct it one at a time. That's actually, yeah, for laziness sake, though, you can parse out the number from n to like have it digit by digit. But I'm gonna be a little bit lazy. Oops, digits is already n digits maybe. As you go to, let's see, right? Weird brackets aside. Okay, and then now we can look at the first. Oh, I guess this is the length of this. And then now we can look at it one digit at a time, right? So here we can do for current digit maybe. I'm using inconsistent notation as well, but I don't know, because that's before I think so. In Python, usually you do snake cases, but in Leetcode they have like weird things, so it confuses me. All right, let's keep it consistent at least. For current digit in, how do we want to do it? Yeah, well, we want the enumeration version, so let's do, let's just say for I in current and enumerate n digits. Okay, so then now the current, we'll do a for loop for the current, right? But only if, so here, keep in mind that we're, maybe another way of phrasing it though is that this only has a 2 prefix if 2 is in the original digits, right? For example. So in that, because, or I mean, there are a couple of ways you can do it, to be honest. I'm going to do it with a for loop, but you could actually do it with, you can do it with a, I want to say prefix sum, or you could do it with prefix sum or binary search on digits, and that's fine too. But basically what you want to do is like, okay, let's say the first digit is 5. You want to count all the 4s and all the before 4s, right? So but the way that I like to write it this way because it generalizes a little bit for me in the future, for other problems, though in this case we can be more specific because it's a very straightforward formula. But yeah, for now, for j, we have is equal to the current digit. We don't want this to be inclusive, but then now we go if j is in digits, which is kind of awkward, I guess. Maybe we could have done like at least for loop until, or for loop for j in digits. Okay, fine. Let's do it this way. Digits, we know that is sorted for j in digits. If j is greater than, or even you go to current, we break, because then now we, let me think about that. If it's exactly in current, what do we do? So the way that I visualize this is thinking, okay, I have an example ready, right? If I have 5, what happens? Well, we go to the next loop, but what happen? How do you handle this one exactly? I guess we handled it pretty okay because we just do. Okay, so I think if this is equal, we can break. But I may have an off by 1, and this is something that will go. Hopefully, I'll remember and not forget later when I do possible off by 1. Let's say this way. But usually, I will keep it in my head, and then if I see something wrong later on, I will go back to be like, okay, because this is sus, right? This is a little suspicious. Not quite sure. It could still be right. It's just that these are things that I think about when I'm writing that out, right? So okay, but okay. So before the break, though, we go. Okay, so now, we know that there's a prefix with j, so then we add the total to n digits of, in this case, it will be length of n, the other n digits. Well, this is terrible, but minus I minus 1 or minus 2. Is it minus 1 or minus 2? Sorry, minus 1 or minus 2, right? For example, here you have 4 digits. So this is gonna give us 4. If we have 0, meaning this is the first index, then we are going to have 3 extra digits. So okay, so I think this is right, but again, this is also sus, and we think about this, right? Okay. And I think that should be good enough to be honest, because if this is for the last digit, it's gonna only give us this will give us 0, which gives us 1. So I think we're okay here. Let's return the answer. Though I think I have it below. Yeah, and let's give it a spin, and then we'll see how at least see if it's wrong. If it's wrong, then we can debug it, right? Oops, I forgot that some of these are in string. Where is this? And didn't I convert it to a list? J. Okay. Oh, this is a string. Huh. That's awkward, actually. Let me convert that as well. I mean, we could also obviously just convert it every time, but that's a little bit awkward, maybe. Okay, so that looks good. But so one thing that you have to think a little bit meta before you submit is that you look at the distribution of the test cases, right? And these are like very ideal situations that could easily be wrong. So that's why we're gonna add more cases that's not included in the test case. Yeah, let's do. This is hard to type, but that's okay. I think we had like some funky numbers here, and then maybe something like this should give us maybe the same number, and then I don't know, just play around a little bit. Yeah, let's give it a spin. We probably could come up more, but well, but first thing first, and we're really wrong. Not really even. Okay, so there is an off by 1 case, so that's good. Oh, okay. I know why we have an off by 1 case. It's because this is good. This if statement is good for everything except for the very last digit. Because then, because if I is equal to whatever, because that means that the exact number, this number n, is a possible number, but we break it off. So there's definitely off by 1, but it seems like from the other places we're a little bit more off by that. Do I overcount? So one thing that I'm thinking about is whether I'm overcounting or undercounting, because that helps. And I think I figured it out when I, because in my mind I have a question, and I said, if my hypothesis is true, then I am overcounting. And then I took a quick look, and I am overcounting in these two, so that's good. And what happened is that I messed up. In that, similar to this one, is the inverse of okay. Basically, what I was doing is that I cut this off and then I go to the next iteration, right? However, we only go to the next digit if the number's already in it. What I mean by that is that, okay, in this case, we have like, okay, 5, 1 is a prefix. That's why we did the loop this way. However, if I have 6, 2, 1, 3, and the digits 1, 2, 3, 4, 5, meaning 6 is not in it, it makes no sense to have like a 6 thing, right? Because we just go, okay, let's just say we do, we have this thing, 3 digit, and then n is equal to 6. Well, I mean, yeah, you can add stuff here, but they cannot exist, right? Because it doesn't matter, because there's no 6 prefix. So that's why I'm wrong here. So that's okay. Okay, so let's figure out both scenarios, which is okay. So I mean, these are 2 different wrong cases. So let's think about this. So okay, so let's separate that out. So if we break. Okay, so if j is equal to current, we go maybe, but let's add a statement, right? Like can move on, go on, move on is equal to force, maybe, and then like something like this, move on, and then if not move on, then we break. So this should at least fix the overcounting. Let's see if I'm lying. And then we should only have the off by 1, right? So okay, so that does fix that, and we have the off by 1. Like we said, we only have off by 1 when sorry, my sound got cut off for a second. I think I was there's some weird thing that I was doing with my Alexa, I think. But okay, anyway. So yeah, so it is off by 1. So like we said, it's just because the final number is in it. So then we just there are a couple of ways you can think about this. Maybe okay, let's say if maybe we can just do like if move on and I is equal to length of n digits minus 1, then we increment total, right? Maybe that should be good enough. I was thinking about doing another way. There are a couple of ways you can handle this. This is an edge case, right? At least an edge case in how we construct our thing. But yeah, so that looks good. Our test case is weird enough that this is confident. Okay, I think I'm okay. Maybe I'll do one more, just adding this one, but with a 6 in it. Though maybe that's the same as the other ones. And maybe I'll just, they have more digits. Maybe that's too many digits though. Okay, I think this is good. Let's give it a spin. Okay, so since that's good, I'm more confident. So let's give it a submit. I did it last time, apparently, about a year ago. And this time, nice. I did get it on the first try. I was worried that I wouldn't. 627 day streak. Yay. So yeah, so what is the complexity? I kind of alluded to this, right? We do it 1 digit at a time. And for each digit at worst, we go for all the possible digits. So this is going to be at most n times d, where d is the number of digit, and n is the number of digits in n, right? So in that sense, it is linear. Because that is this is quadratic, I suppose, because the size of the input is the number of bytes, which is the number of digits, and the number of things in n. But yeah, that's all I have for space. I guess we reconstruct this away, but you could have just cast an int, but that's a little bit awkward if you ask me. Again, I don't know. There are a couple of weird things here that you can optimize if you really care about space, but maybe that's a little bit awkward. So I don't know. Use your own discretion. Okay, let's take a quick look to see what I did last year. Probably did the same. I did do a sort because I guess I missed it. But I did the same idea here. But I did it recursively. Okay, I guess recursion works too. That's a good idea as well. So yeah, I mean, okay. Cool. That's all I really have for this one. I probably have a video if you want the recursive explanation. So check that out. And that's pretty much all I have. Hit the like button, hit the subscribe button, join me on Discord. Hope y'all have a great weekend, a great Friday, great Saturday, wherever you are, whenever you're watching it. Stay good, stay healthy, to good mental health. I'll see you later, and I don't know, goodbye.